Hi, welcome back. On today's lecture series, we are going to see about the differential protection of alternator. So, the most common system which used for the protection of stator winding fault, it employs circulating currents principle, or it may be called as merge price circulating current scheme. So, in this scheme of protection, the current at the two end of the potential section which is compared. In a normal operating condition, these current are equal but may become unequal on the occurrence of a fault in the protected section. The difference of current under faulty condition is arranged to pass flow through the operating coil of the relay. The relay then closes its contact to isolate the faulty section of the system. The system is also known as merge brace circulating current scheme. So this is the construction. Here there are two identical current transformers, that is one side is nothing but CT1 and the another side is nothing but CT2, are placed on the either side of the each phase of the stator winding. One is in the primary side and one is in the secondary side. Okay, so like that. And the secondary of each set of CT are connected in star connection, and the two neutral point and the corresponding terminal of the two star groups being connected together by means of four core pilot cable. Thus, there is an independent path for the current circulating in the pair of current transformers and the potential. And here the relay coil are connected in star and the neutral point being connected in the current transformer. Here a common neutral and the outer end, one end of the three pilot. In order that burden on each CT is the same, the relay are connected across equipment points, the three pilot wire, and these equipment points would naturally be located at the middle of the pilot wire. The relay are generally electromagnetic type and are arranged for instantaneous action, since fault should be cleared as quickly as possible. So this is a schematic diagram. So in the schematic diagram, so just we can take this is an alternator winding, R phase winding, Y phase winding and B phase winding. So this is R phase, Y phase and B phase, and all the three phases are connected in star connection. And this terminal is called a neutral. This neutral connected is connected with a ground through this earthing resistance. And here we are inserting the current transformer on the primary side of the alternator and the secondary side of the alternator. Here for all each phases we are using two CT, one is primary and another secondary. So primary, secondary. So totally we are using 6 current transformer. So all the three will be called as CT1, and the primary side all the three will be called as CT2, that is nothing but secondary. Okay. So here the all the CTs are connected in this star connection. Okay la. So this star connection and as well as the secondary of star connection will be interconnected, and between the R phase to neutral, Y phase to neutral and B phase to neutral, so there will be in between an operating coil will be there. So at this stage here the CT it measures as a 10 amps. Okay, here also it measures as 10 amps. So the both current will be measured. If the primary current and secondary current will be equal, so there is no differential current. And if the primary current is 20 amps and the secondary current is 10 amps, so the difference is 10 amps, the differential current will flow through the operating coil. So the operating coil is getting energization and it trips the circuit breaker. Okay. So this is the main operation. So here actually we can able to protect the earth fault as well as face to face fault and such as some other earth fault, etc. So if the differential current is there, the differential current is flowing through the operating coil. The operating coil is getting energization. So because of this energization, it acts as an electromagnet. It pulls the handle so that it pulls the contacts so that the circuit breaker gets open. We can able to isolate the faulty section. And this is the assessment. Which type of relay represent the phasor difference of two or more similar electrical quantity which exceed a predetermined value. An overload relay, differential relay, over voltage relay, and thermal relay. So put your answer in the comment section, and these are the few reference books. Thank you.